Now in this lecture we'll answer two questions. In the first question we'll find out the radius of this circle, and in the second question we'll find out the area of this green shape. So we'll start with the first question. In the moment we have a circle. From this common standpoint, point A, we have two tangents to this circle, tangent AP and tangent AQ. In addition, we have the first tangent to this circle, that is tangent BC, equals to 14 units in Islam. Then when you find the point of tendency of tangent BC with this circle, this point is point M. We define the center of this circle. This point is point O. We define the radius of this circle, R. That is the radius that we are looking for this question. And we will join points O and Q together by a straight line. Point Q is the point of tendency of tangent AQ with this circle. Point O is the center of this circle. Point Q is the point of the circle itself. Therefore, OQ is the radius of this circle. Is equals to R. The radius OQ is equals to R. The radius OQ is drawn to point Q, that is the point of tendency of tangent AQ with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees according to rule 1. Point P is the point of tendency of tangent AP with this circle. So we join points O and P together by a straight line. OP is of course the radius of this circle. This equals to R. The radius of OP is equals to R. The radius of OP is drawn to point P, that is the point of tendency of tangent AP with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle equals to 90 degrees according to rule 1. The same rule 1. So here we can implement also rule 2 in our drawing. So repeat quickly rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing, we have a circle. This is the common standpoint point P. From this common standpoint point P, we have two tangents to this circle. Tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. Because in our drawing, if we focus at this common standpoint point B, from this common standpoint point B, we have two tangents to this circle, tangent BP and tangent BM. And according to rule 2, they are equal to each other. So if we define the length of tangent PB as x, then the length of tangent BM must be also equal to x because they are equal to each other according to rule 2. What is the length of this missing line thread MC? From the drawing it is very easy to see that MC in total equals to BC minus BM. This is not the missing line thread MC is equal to BC minus BM. So MC equals to BC is 14 according to what is given to the question, minus BM, BM is x. So in total we should know that MC equals to 14 or 6 units in its length. The next step, we focus at this coming standpoint, point C. From this coming standpoint, point C, we have two tangents to the circle. Tangent CQ and tangent CM. According to also, they are equal to each other. That is to say, CM equals to CQ. But CM equals to 14 minus 6, therefore CQ must be also equal to 14 minus 6 units in its time. In the next step, we focus on this coming standpoint, point A. From this coming standpoint, point A, we have two tangents to this circle, tangent AQ and tangent AP. And according to also, they are equal to each other. That is to say, AP equals to AQ. That is down. According to rule 2, tangent AP is equal to tangent AQ in its length. AP in total equals to AB, that is 16, plus BP, that is X. So in total, AP equals to 16 plus X. And this equals to AQ. AQ in total equals to AQ equals to QC, that is 14 minus X, plus C8, that is 18. So in total AQ equals to 14 minus X plus 18. So here we have 14 plus 18 is 32. So this expression in total equals to 32 minus X. Those two sides of the equation are equal to each other. That is to say, 16 plus X equals to 32 minus X. 16 plus X equals to 32 minus X. Here we subtract 16 from this equation. Here 16 will get cancelled. This side of the equation we left only with X equals to 32 minus 16 is 16 minus X. This side of the equation only with 16 minus X. So in total we should find out that X equals to 16 minus X. Here we add X to this equation. So here X minus X is 0, so we left in this side of the equation with 16. Here X plus X is 2X. So in total we found out that 2X equals to 16. Here we divide this equation by 2. And finally get that X equals to 16 over 2 is 8. X equals to 8 units in its length. Now 7 PB equals to X and X equals to 8, so write it down. Likewise, BM also equals to X and X equals to 8. Here, answer MC equals to 14 minus 6, that is to say it is equals to 14 minus 8, that is 6. So 14 minus 6 equals to 6. Here 14 minus 6, QC, answer QC equals to 14 minus 6, that is 6. So in the next step, we will join points O and A together by a straight line. By joining points O and A, we can derive those two right angles. This is the upper right angle OPA and this is the lower right angle OQA. What is the area of the big quadrilateral APOQ? The area of the big quadrilateral A P O Q must be equal to the sum of the errors of the two components that it consists of. Quadrilateral APOQ consists of those two components. So for the error of this quadrilateral APOQ must be equal to the error of this first component that it consists of. This is actually the error of this right upper triangle APO. Plus the error of the second component that quadrilateral APOQ consists of. This is actually the error of this lower right triangle OQA. So in total, we can find out that the error of this big quadrilateral APOQ is equal to the area of the first component that is consists of. This is actually the area of the upper right triangle APO plus the area of the second component that quadrilateral APOQ consists of. This is actually the area of the lower right triangle OQA. So in total, we get that the area of the big quadrilateral OPOQ is equal to the area of the upper right triangle APO. What is the area of this upper right triangle? Actually, what is the area of this upper right triangle APO? The area of this upper right triangle APO must be equal to the base AP times the height PO over 2. This is the base AP times the height PO over 2. Likewise, the second component that the big quadrilateral APOQ consists of is this right lower triangle OQA. So what is the area of this right lower triangle OQA? Is equal to the base AQ times the height QO over 2. So AQ times QO over 2. And again, the area of this right lower triangle OQA equals to the base AQ times the height to the base QO over 2. AP in total equals to PB that is 8 plus B8 that is 16. So in total AP equals to 8 plus 16 that is 24. AP equals to 24 times the height PO. PO is the radius of this circle, equals to R over 2. So in total we should find out that the area of this upper right triangle OPA is equal to 24R over 2 plus the area of this lower right triangle OQA is equal to AQ. AQ in total equals to QC 36 plus C8 is 18. So in total QA equals to 16. QA in total equals to 8. QA in total equals to 6 plus 18, that is 24. Times QO. QO is the radius of this circle, that equals to R. That is the radius that we are looking for in this question. Over 2. So in total we found out that the area of the big quadrilateral APOQ is equal to 24R over 2. That is 12R plus 12R. 12R plus 12R is 24R. So in total we found out that the area of the big quadrilateral APOQ, according to the first method of calculation, is equal to 24R square root in its size. And again, we have this big quadrilateral APOQ is equal to 24R square root in its size. In the next step, I will delete this straight line AO. and we will join points O and M together by side line. Point O is the center of the circle, and point M is the point of tendency of the BC with this circle. Repeat again, point O is the center of this circle, point M is the point of the circle itself, because of the fact that it's a tangent. This is the point of tendency of tangent BC with this circle. Therefore, OM is the radius of this circle. This is equal to R. The radius OM is equal to R. The radius OM is drawn to point M. That is the point of tendency of tangent BC with this circle. Whenever your radius is drawn to the point of tendency, then tangent BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees in its size. This angle also equals to 90 degrees in its size according to rule 1. In the next step, we join points O and C together by side 9. And we join points O and B together by side line. By doing those constructions, we can determine 1, 2, 3, 4 right angles. So we calculate the area of each of them separately, and then we add all the areas together. The next step. So what is the area of this triangle of POB? The area of this right triangle POB equals to the base OP, that is R, times the height PB, that is 8 over 2. So in total, the area of this the area of this small right triangle OPB is equal to 8R over 2. 8R over 2 is 3R. Plus the area of this small right triangle OMB is equal to the base BM, that is 8, times the height MO, that is R over 2. So in total, the area of this right triangle OBM equals to 8R over 2, that is 4R. Exactly like the area of this triangle POB. What is the area of this triangle right triangle OMC? The area of this right triangle OMC equals to the base CM, that is 6, times the height MO, that is R over 2. So in total, the area of this right triangle OMC is equal to 6R over 2. 6R over 2 is 3R. Plus the area of this right triangle OQC. The area of this right triangle OQC is equal to the base QC, that is 6, times the height QO, that is R over 2. So in total, the area of this right triangle OQC is equal to 6R over 2. 6R over 2 is 3R. So the sum of the areas of those all 4 right triangles, in total it equals to 4R plus 4R is 8R. 8R plus 3R is 11R, and 11R plus 3R is 14R. So in total, the sum of the areas of those all 4 triangles, is equal to 14R coordinates in their sizes. So therefore, the area of this big quadrangle APOQ must be equal to the sum of the areas of those 4 right triangles, that is 14R, plus the area of this triangle ABC, that is the missing triangle. Repeat again, the area of this big quadrangle APOQ according to the second method of calculation must be equal to the sum of the areas of those 4 right triangles, that is actually 14R, plus the area of this green triangle ABC. So if you found out that according to the second method of calculation, the area of this one big quadrangle APOQ in total is equal to the sum of the areas of those all 4 right triangles, that is actually 14R, so it's in their sizes, plus the area of this missing triangle, ABC. So in the next step, we'll find out the area of this missing green triangle, ABC. Actually, we have a special formula for the area of any triangle. Here, triangle ABC could be any triangle. The area of triangle ABC, according to the new formula, is equal to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter of triangle ABC, that is area that we're looking for. And the non-S is the semi-perimeter of the triangle that is area we are looking for. The semi-perimeter of any triangle equals to the perimeter over 2. And the perimeter of any triangle is equal to the sum of its 3 side lengths. In our case, the perimeter of this triangle ABC equals to 16 plus 14 plus 18. If we divide the perimeter by 2, we get the semi-perimeter of this green triangle, ABC. So here we have 16 plus 14 is 30, 30 plus 18 is 48, and 48 over 2 is 24. So in total we should know that the semi-perimeter S of triangle ABC, of our triangle ABC, is equal to 24 units in its length. In this general formula for the area of any triangle, A, B, and C are the side lengths of the triangle that is area that you are looking for. So around our triangle ABC, we choose A is S16, we choose B as 14, and we choose C as 18. So actually have all the data that is needed in order to find out the area of our green triangle ABC. Just have to put the data of our specific triangle ABC in this general formula for the green triangle, and this way we find out the area of our green triangle ABC. So we do it now, we get that the area of our triangle ABC is equal to the square root of S is 24 times S minus A. S minus A is 24 minus 16 times S minus B. S minus B is 24 minus 14 times S minus C. S minus C is 24 minus 18. And so we found out that the area of our green triangle ABC is equal to the square root of 24 times 24 minus 16 is 8 times 24 minus 14. 24 minus 14 is 10 times 24 minus 18. 24 minus 18 is 6. So in total we found out that the area of our green triangle ABC is equal to the square root of 24 times 8 times 10 times 6. Actually, the value of this expression in total is equal to 107.33 square units in size. In total, we found out that the area of this green triangle ABC is equal to 107.33 square units in its size. Write it down. So the area of this green triangle ABC is equal to 107.33 square units in size. And therefore, the area of this big quadrangle AP or Q according to the second method of calculation is equal to the sum of the areas of those all four right angles, that is actually 14R, plus the area of this green triangle ABC is equal to 107.33 square units in size. This is according to the second method of calculation of the area of the big quadrangle AP or Q. But according to the first method of calculation, we only found out that the area of the same quadrangle AP or Q is equal to 24R square units in size. So we have two equations for the area of the same quadrangle AP or Q. Therefore, we create equation 3 that says that the area of the big quadrangle AP or Q according to the first method of calculation must be equal to the area of the same quadrangle AP or Q according to the second method of calculation. A simple equation. So the area of the big quadrangle AP or Q according to the first method of calculation is equal to 24R units in size, and it must be equal to the area of the same quadrangle AP or Q according to the second method of calculation, which is actually 14R plus 107.33. So in total, we should find out that according to equation 3, (24R) equals to 14R plus 107.33. Here we subtract 14R from this equation, equation 3. Again, that according to equation 3, 24R minus 14R is 10R, equals to 14R minus 14R is 0. So we left only with 107.33 in this side of the equation. Here we divide this equation by 10 and find again that the radius of the circle, that is the radius of R, the radius of the circle that we are looking for, R equals to 107.33 over 10 is equal to 10.733 units in its length. Repeat again, if we found out in total that the radius that we are looking for this question, that is the radius of this circle R equals to 10.733 units in its length. So we finish with the first question. In the next step, I present you the second question, and we solve the second question of this lecture. The second question, our task is to find out the area of this green shape. So in the drawing we have three semicircles. This is the biggest semicircle, this is the medium semicircle, and this is the smallest semicircle. In addition, we have this rectangle. The area of this rectangle is equal to 4 square units in size. And finally, we have this quarter circle. Again, our task is to find out the area of this green shape. So in the first step, we define the length of this rectangle as x. And the width of this rectangle is y. We know that the opposite sides of a rectangle are equal to each other. So this side of this rectangle are equal to each other, but this side equals to y, therefore this side must be also equal to y units in its length. This is a quarter circle. Those two sides are the area of this quarter circle, and therefore they must be equal to each other in their lengths. The radius of this quarter circle is y, so this is also the radius, that must be also equal to y. Actually, it doesn't seem, doesn't like that they are equal to each other in their lengths, but it is the problem with the drawing. Okay? They are equal to each other in their sizes, but from the drawing it is, you can see clearly that the length of this side segment is longer than the length of this side segment, but it is the problem with the drawing itself. We know that those two radii of this quarter circle are equal to each other, so each radii equals to y units in its length. So ignore the drawing. Those two radii of this quarter circle are equal to y each of them. So what is the diameter of this biggest semicircle? The diameter is x plus y, and therefore the radius must be equal to x plus y over 2. So it is done. We should find out that the radius of this biggest semicircle is equal to x plus y over 2 units in its length. The radius of the biggest semicircle is equal to x plus y over 2 units in its length. The radius of this medium semicircle equals to the diameter x over 2. So it is x over 2 units in its length. The radius of the medium semicircle is equal to x over 2 units in its length. And finally, the radius of this smallest semicircle equals to the diameter y over 2. So it is y over 2 units in its length. So the radius of the smallest semicircle equal to y over 2 units in its length. So in total, we found out that the radius of the biggest semicircle is equal to x plus y over 2 units in its length. The radius of the medium semicircle equals to x over 2 units in its length. And finally, the radius of the smallest semicircle is equal to y over 2 units in its length. Our task is to find out the area of this green shape. So what is the area of this green shape? So from the drawing, it is very easy to see that the area of this green shape equals to the area of the biggest semicircle minus the area of this medium semicircle minus the area of this smallest semicircle. Repeat again, the area of this green shape in total it is equals to the area of the biggest semicircle minus the area of this medium semicircle minus the area of this smallest semicircle. So write it down. We should found out that the area of the green shape, that is the area that we are looking for this question, is equal to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. The radius of this biggest semicircle equals to x plus y over 2 units in its length. The radius of this medium semicircle equals to x over 2 units in its length. And we already found out that the radius of the small semicircle equals to y over 2 units in its length. So, the value of this expression is the area of the green shape. So what is the area of the biggest semicircle? Actually, we know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. So it is pi over 2 times the radius of this biggest semicircle squared. This is actually x plus y over 2 squared. Minus the area of this medium semicircle, that equals to pi over 2 times the radius of this medium semicircle squared. That is actually x over 2 squared. Minus the area of this smallest semicircle, that actually equals to pi over 2 times the radius of this smallest semicircle squared. That is actually pi over 2 squared. Y over 2 squared. Actually. So the value of this expression in total equals to the area of the green shape, that is the area that we're looking for this question. So we just simplify those three expressions and get the area of the green shape. So here we have pi over 2. We have here x plus y over 2 squared. This is really x plus y squared over 2 squared. 2 squared is 4. So in the denominator of this expression we have 2 times 4, that is 8. Here we have this expression minus pi over 2 times x over 2 squared. X over 2 squared equals to x squared over 4. So here in the denominator of this expression also we have 2 times 4, that is 8, minus pi over 2 times y over 2 squared. Y over 2 squared equals to y squared over 4. So likewise in this denominator of this expression we have also 2 times 4, that is 8. Therefore we can take out 8 as a second factor out of those three expressions, or we can build a common factor in the denominator that is 8, because of the fact that the denominator of those three expressions is equals to 8. So 8 will be the denominator of all those three expressions. That is to say, we take 8 as a common factor out of those three expressions. In the denominator of this expression we have pi times x plus y squared. That is actually pi times x plus y squared. X plus y squared equals to x squared plus y squared plus 2 times x times y. Minus, in the denominator of this expression we have minus pi x squared. Minus pi x squared. The denominator of this expression we have minus pi y squared. So here the value of this expression in total is equal to the area of the green shape, that is the area that we're looking for this question. Here we'll open the brackets of this expression. So it is pi x squared plus pi y squared plus 2 pi xy divided by 8. Here we have also this expression, of course. This is minus pi x squared minus pi y squared. Here we have pi x squared minus pi x squared is 0. We have a pi y squared minus pi y squared, this is also 0. So in the numerator of this expression, we have to only 2 pi xy. So they have the green shape in total. Is equal to 2 pi xy over 8. And again, if you want to know that they have this green shape, in total it is equal to 2 pi xy over 8. Here we divide both the numerator and the denominator of this expression by 2. 2 over 2 is 1, so we left only with pi x squared in the numerator. Pi times xy, of course, in the numerator. Well, in the numerator we have 8 over 2 is 4. So in total, we found out that they are of this green shape is equal to pi xy over 4. Xy, x times y is 4. So we found out that x times y is the area of this rectangle. This is equals to 4 according to what is given in the question. X times y is 4. So we can substitute x times y here by 4. We get that pi over 4, x times y is 4. So here we have 4 in the numerator, 4 in the numerator, so 4 will get cancelled, and we left only with pi. So in total we found out that they are of the green shape, that is the area that we are looking for in this question, equal to 4 square root in size. Equals to pi, of course. Pi square root in size. Okay, again, we found out that the area of this green shape, that is the area that we're looking for in this question, is equal to pi square root in size. So we finish with the second question. In the next step, as soon as the lecture, we start with the repetition of the solution of the first question, and then we repeat the solution of this second question. In the first question, our task is to find out the radius of this circle. So in the drawing, we have a circle. From this coming some point A, we have two tangents to this circle, tangent AP and tangent AQ. In addition, we have this third tangent BC, the center to this circle and this point. We should define the point of tendency of tangent BC with this circle. This point is point M. The point of tendency of tangent BC with this circle is here at point M. In addition, we know that this is line 70 AC, this is equals to 18 units in its length. This is line 70 AQ, this is equals to 16 units in its length. Again, our task is to find out the radius of this circle. Again, the point of tendency of tangent BC with this circle, this point is point M according to our definition. We define the center of this circle, this point is point O. When we define the radius of this circle is R. R is the radius that we are looking for in this question. Point Q is the point of tendency of tangent AQ with this circle. So in the next step, we join points O and Q together by side line. Point O is the center of the circle, point Q is the point of the circle itself, therefore OQ is the radius of the circle, is equals to R. The radius of Q is equals to R, the radius of Q is drawn to point Q, that is the point of tendency of tangent AQ of this circle. Whenever your radius that is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this circle equals to 90 according to all 1. Point P is the point of tendency of tangent AP with this circle. We join points O and P together by side line. OP is of course the radius of this circle is equals to R. The radius of P is equals to R. The radius of P is drawn to point P, that is the point of tendency of tangent AP with this circle. Whenever your radius is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle equals to 90 degrees according to the sum rule 1. In the next step, implement rule 2 in our drawing. Pin click on rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing, we have a circle. This is the common standpoint point P. From this common standpoint point P, we have two tangents to this circle. Tangent PA and tangent PP. And according to this rule 2, they are equal to each other. This is to say PA equals to PP. So can we implement rule 2 in our drawing? One put in our drawing. If we focus at this common standpoint point B, from this common standpoint point B, we have two tangents to this circle, tangent BP and tangent BM. And according to rule 2, they are equal to each other. That is to say BP equals to BM. So if we define the length of tangent BP as x, then the length of tangent BM must be also equal to x because they are equal to each other according to rule 2. Likewise, so here we have BM equals to x, therefore the missing line segment MC must be equal to BC minus BM. Repeat again. The missing line segment MC must be equal to BC minus BM. BC is 14, BM is x. So in total, MC equals to 14 minus x. The line segment MC of tangent MC equals to 14 minus x units in itself. So in the next step, we focus at this common standpoint point C. From this common standpoint point C, we have two tangents to this circle, tangent CQ and tangent CM. And according to rule 2, they are equal to each other. That is to say, CM equals to CQ, but CM equals to 14 minus x, therefore CQ must be also equal to 14 minus x units in itself, according to rule 2. In the next step, we focus at this common standpoint point A. From this common standpoint point A, we have two tangents to this circle, tangent AQ and tangent AP. And according to rule 2, they are equal to each other. That is to say, AP equals to AQ. And again, according to rule 2, tangent AP equals to tangent AQ in its length. AP in total equals to 8 plus 16. AP in total equals to x plus 16. And again, AP equals to x plus 16. This equals to QA. QA in total equals to 14 minus x plus 18. Again, QA in total equals to QC, that is 14 minus x, plus C8, that is 18. So in total, if you know that QA equals to 14 minus x plus 18. Here, 14 plus 18 is 32, so in total this expression equals to 32 minus x. Those two sides of the equation are equal to each other. That is to say, 16 plus x equals to 32 minus x. So here we subtracted 16 from this equation, so here 16 will get cancelled, we left only x in this side of the equation, while on the other side of the equation we have 32 minus 16, that is 16. So in total this side of the equation we left only 16 minus x. So in total we should find out that x equals to 16 minus x. So here we added x to this equation, and we found out that 2x equals to 16. Here we divided this equation by 2, and we found out that x equals to 16 over 8. 16 over 2 is 8. This is line segment PB equals to x, and x equals to 8. Likewise, PM equals to x and x equals to 8. This line 7 cm or tangent cm equals to 14 minus x, that is to say this is 14 minus 8, that is 6. Likewise QC also equals to 14 minus x, that is 6. So in the next step, we join points A and O together by straight line. By joining points A and O, we get those two right triangles. This is the big right triangle OPA, and this is the lower right triangle OQA. Again, this is the upper right triangle OPA. This is the lower right triangle OQA. So actually, the area of this big quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. The first component that the big quadrilateral OQ consists of is this right upper triangle OPA, and the second component that the big quadrilateral APOQ consists of is this right lower triangle OQA. And therefore, the area of the big quadrilateral OPOQ must be equal to the sum of the areas of those two components that it consists of. Again, according to the first method of calculation, the area of the big quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. The first component that the big quadrilateral APOQ consists of is the upper right triangle APO, according to the area of the upper right triangle APO, plus the area of the second component that it consists of. The second component that the big quadrilateral APOQ consists of is the lower right triangle OQA, plus the area of the second component, that's actually the area of the right lower triangle OQA. So in total, the area of the big quadrilateral APOQ must be equal to the area of the first component, it's actually the area of triangle APO, plus the area of the second component that it consists of, is actually the area of the right lower triangle AQA. What is the area of this upper right triangle OPA? It is equals to the base AP times the height P over 2. And again, the area of this upper right triangle OPA equals to the base AP times the height P over 2. Likewise, what is the area of this lower right triangle OQA? It is equals to the base AQ times the height QO over 2. And again, the area of the right lower triangle OQA is equal to the base AQ times the height QO over 2. AP is 16 plus 8, that is 24, times PO is R over 2. So total AP times PO over R is equal to 24 R over 2. Likewise, QA is 18 plus 6, that is 24. QO is R over 2. So in total, the area of this triangle OQA equals to 24 R over 2. And you get the area of the lower right triangle OQA is equals to AQ times Q over 2. It is actually 24 R over 2. So in total, the area of the big quadrilateral APOQ equals to 24 R over 2 plus 24 R over 2. 24 R over 2 is 12 R, so it is 12 R plus 12 R, that is 24 R. So in total, we found out that according to the first method of calculation, the area of this big quadrilateral APOQ is equal to 24 R square units in size. In the next step, I deleted this straight line AO. And again, I deleted this straight line AO. And then we join points O and M together by straight line. Point M is the point of tendency BC with this circle. Point O is the center of this circle. Point M is the point of the second step. Therefore, 1 is the radius of the second. It's equals to R. The radius of M that is equals to R. The radius of M is drawn to point M, that is the point of tendency BC with this circle. Whenever we have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius of MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. By doing those constructions, before that, we join points O and B together by straight line. We join points O and C together by straight line. By doing all those constructions, we get there 4 right angles. 1, 2, 3, 4. The next step, we calculate the area of each of them separately. the area of this small right triangle OPB equals to the base PB times the height PO over 2. This is really 8 times R over 2. 8 R over 2 is 4R. Likewise, the area of this triangle right triangle OBM is equal to the base BM. This is really 8 times the height MO, that is R over 2. So in total it is 8 R over 2, that is 4R. Likewise, the area of this right triangle OMC equals to the base CM, that is 6, times the height, that is R over 2. So in total, the area of this right triangle OMC equals to 6R over 2, that is 3R. Finally, the area of this right small triangle OQC equals to the base QC, that is 6, times the height QO, that is R over 2. So in total, the area of this triangle QOC equals to 6R over 2, that is 3R. So in total, the sum of the areas of those all 4 right triangles is equal to 4R plus 4R is 8R. 8R plus 3R is 11R, and 11R plus 3R is 14R. So in total, the sum of the areas of those all 4 right triangles is equal to 14R coordinates in their sizes. The area of this big quadrilateral APOQ according to the second method of calculation must be equal to the sum of the areas of those 4 right triangles, that's actually 14R, plus the area of this green triangle ABC. Again, the area of this big quadrilateral APOQ according to the second method of calculation is equal to the sum of the areas of those 4 right triangles, that is actually 14R square units, plus the area of this green triangle ABC. So our test is to find out the area of triangle ABC. This is the only missing thing here. Because we already found out that the sum of the areas of those 4 triangles is equal to 14R. So actually we have a special formula that is true for the area of any triangle. According to the formula, this is a triangle ABC that could be any triangle. Triangle ABC could be any triangle. So the area of triangle ABC that could be any triangle equals to the square root of S times S minus 3 times S minus 3 times S minus 3. S is the semi-perimeter, that is the area that we are looking for. The semi-perimeter of any triangle equals to the perimeter over 2. The perimeter of any triangle is equal to the sum of its side lengths. And if we divide the perimeter by 2, we get the semi-perimeter S. The semi-perimeter S. So the perimeter of this green triangle equals to 16 plus 14 plus 18. 16 plus 14 is 30. 30 plus 18 is 48. So the perimeter of triangle ABC, our green triangle, is equal to 16 plus 14 plus 18, that is 48. If we divide the perimeter by 2, we get the semi-perimeter. So it is 48 over 2, that is 24. So in total, we found out that the semi-perimeter of this green triangle ABC is equal to 24 units in its length. In this formula, A, B, and C are the side lengths of this triangle ABC, that is area that we are looking for. We choose A is 16, B is 14, and C is 18. Those are the side lengths of this green triangle ABC. And again, we choose A is 16, B is 14, and C is 18. And the semi-perimeter is 24. So we have all the data that is needed in order to find out the area of this green triangle ABC. We just have to put the data inside this general formula for any triangle. In this way we find out the area of this specific green triangle ABC. So we did it, and we found out that the area of our green triangle ABC equals to the square root of S is 24 times S minus A. S minus A is 24 minus 16 times S minus B. S minus B is 24 minus 14 times S minus C. S minus C is 24 minus 18. So in total, we found out that the area of our green triangle ABC equals to the square root of 24 times 24 minus 16 times 24 minus 14 times 24 minus 18. So it is equal to the square root of 24, and 24 minus 16 is 8, times 24 minus 14 is 10, times 24 minus 18 is 6. So in total, we found out that the area of our green triangle ABC is equal to the square root of 24 times 8 times 10 times 6. Actually, the value of this expression in total is 107.33. So in total, we found out that the area of this green triangle ABC is equal to 107.33 square in its size. And again, they have this great triangle ABC is equal to 107.33 square units in size. And therefore, in total, according to the second method of calculation, the area of this big quadrilateral APOQ must be equal to the sum of the areas of those four right angles, that's actually 14 now, plus the area of this great triangle ABC. Then again, the area of the big quadrilateral APOQ according to the second method of calculation must be equal to the sum of the areas of those four right angles, that's actually 14 now, plus the area of this great triangle ABC, that is 107.33. Well, according to the first method of calculation, we already found out that the area of the big quadrilateral APOQ equals to 24R. So we have two equations for the area of quadrilateral APOQ. Therefore, we create equation 3 that says that the area of quadrilateral APOQ according to the first method of calculation must be equal to the area of the same quadrilateral APOQ according to the second method of calculation. The area of the big quadrilateral APOQ according to the first method of calculation equals to 24R. It must be equal to the area of the same quadrilateral APOQ according to the second method of calculation, that actually equals to 14R plus 107.33. So in total, according to equation 3, we found out that 24R equals to 14R plus 107.33. Here we subtracted 14R from this equation, so here 24R minus 14R is 10R. And in this end of the equation, we have 14R minus 14R is 0, so left only 107.33. So in total, we found out that 10R equals to 107.33. Here we divide this equation by 10 and finally found out that R equals to 10.733 units in incident. The radius of this circle, that is the radius that we're looking for in this question, is equal to 10.733 units in incident. So we finish to repeat on the first question. In the next step, repeat on the solution of the second question. In the second question, our task is to find out the area of this green shape. So in the drawing, we have three semicircles. We have three semicircles. This is the biggest semicircle, this is the medium semicircle, and this is the smallest semicircle. In addition, we have also this rectangle. We know that the area of this rectangle is 4 square units in size. And finally, we have also this quarter circle. Again, our task was to find out the area of this green shape. In the first step, we define the length of this rectangle as x and the width as y. We know that the area of this quarter circle equals to, the area of this rectangle equals to 4 square units in size. But you also know that the opposite sides of a rectangle are equal to each other. So those two sides are equal to each other. Those two opposite sides are equal to each other. But this side equals to y, therefore this side must be also equal to y units in its length. This is a quarter circle. Those two sides are defined as the radii of the quarter circle, and therefore they must be equal to each other in the lengths. This length is 1, therefore this length must be also equal to 1 in its length. It is very clear that they are not equal to each other in the lengths according to the drawing, but you should assume that they are equal to each other. Their lengths. The problem is with the drawing itself. It is very difficult to draw this drawing, so the problem is with the drawing. This is y and this is y. Consider the two radii of this quarter circle. The diameter of this biggest semicircle equals to x plus y, and therefore the radius is x plus y over 2. Likewise, the diameter of this medium circle is x, therefore the radius of this medium circle equals to x over 2 units in its length. And finally, the radius of this smallest semicircle equals to the diameter y over 2. That is y over 2 units in its length. Repeat again. The radius of the biggest semicircle equals to x plus y over 2 units in its length. the radius of the medium semicircle equals to x over 2 units in its length, and finally the radius of the smallest semicircle equals to y over 2 units in its length. Okay, again, that our task is to find out the area of this green shape. So what is the area of the green shape? From the drawing, it is very easy to see that the area of this green shape in total equals to the area of the biggest semicircle minus the area of this medium semicircle minus the area of this smallest semicircle. And again, the area of this green shape, it is very easy to see from the drawing that the area of the green shape in total equals to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. The radius of the biggest semicircle is s plus y over 2. The radius of the medium semicircle equals to x over 2, and the radius of the smallest semicircle equals to y over 2. So the area of this biggest semicircle, actually we know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. Therefore the area of this semicircle must be equal to pi times the radius of this semicircle squared, that is actually x plus y over 2 squared, divided by 2. So in total equals to, the area of this semicircle equals to pi over 2 times x plus y over 2 squared. Minus the area of this medium semicircle is equals to pi times the radius of this semicircle squared, that is actually x over 2 squared over 2. So in total the area of this medium semicircle equals to pi over 2 times x over 2 squared. Minus the area of this smallest semicircle, that is actually equals to pi times the radius of this smallest semicircle squared, that is actually y over 2 squared divided by 2. So in total the area of this smallest semicircle equals to pi over 2 times y over 2 squared. The next step, we just simplified all those three expressions. Here we have pi over 2 times x plus y over 2 squared. And here we have pi over 2 times x over 2 squared. X over 2 squared equals to x squared over 4. So in total, the value of this expression equals to pi over 2 times x squared over 4. Minus the value of this expression, in total it is equals to pi over 2 times y over 2 squared. Y over 2 squared equals to y squared over 4. So here we have 2 times 4 is 8, 2 times 4 is 8, and 2 times 4 is 8. So it took 8 a second factor out of those three expressions. So in the denominator of those three expressions we have 8. And in the numerator of this expression we have pi times x plus y squared. To say it is pi times x plus y squared. X plus y squared equals to x squared plus y squared plus 2 times x times y. Minus, in the numerator of this expression we have minus pi x squared. In the numerator of this expression we have minus pi y squared. So in total we found out that the area of the green shape equals to pi times x squared plus y squared plus 2 times x times y minus pi x squared minus pi y squared over 8. Here we open the brackets of this expression. So here we have pi x squared plus pi y squared plus 2 times pi times x times y. And we also minus pi x squared minus pi y squared. Pi x squared minus pi x squared is 0, and pi y squared minus pi y squared is 0. So we left only with 2 pi xy, 2 pi xy over 8. In the numerator, and again we left only in the numerator with 2 pi xy over 8. Here we divided both the numerator and the denominator of this expression by 2. 2 over 2 is 1, so in the numerator we left only with pi xy. And in the denominator we have 8 over 2 is 4. So in total the area of the green shape equals to pi times xy over 4. But we already found out that xy equals to 4, so send xy here by 4. So it is pi times 4 over 4. We have 4 in the numerator, 4 in the denominator, so 4 will get cancelled, and we left only with pi. So in total we found out that the area that we were looking for in this equation, that is the area of this green shape, is equal to pi square units in its size. Okay, thank you very much.